Uh, Good afternoon to all. Hello, hello, to Mr. Rishi Sharma. Am I audible to you?
Sir. Yes, sir, you are audible. Yes, sir.
Okay, fine. Thank you, thank you. Actually, I just talked with Prajot. You were having some issues. That's what I
Yeah, I just logged in, sir.
Yeah, yeah. Thank you, thank you. So we'll be starting. Let me just introduce to you. Okay, so welcome back, participants, after the break. This session is all about introduction to cloud storage, and we'll have the speaker, Mr. Rishi Sharma from Microsoft Azure. And his current designation is a Senior Cloud Solution Architect, and he has BE in Electrical and Electronics from Manipal Institute of Technology, passed out in the year 1997, and he has a long range, 23 years of working experience in organization of reports in India and abroad also, maybe Microsoft, IBM, DXC, Verizon, and Pfizer. And he has, more than 12 years of public clouds, which is AWS, Amazon, while service and Azure experience. And he has worked in the capacity of an enterprise architect and cloud architect, and also in principal architect in varied places, in varied international companies. Welcome once again to you, Rishi Sharma, and over to you.
Thank you, sir. Thank you very much. I hope I am audible to everyone.
Yes, you are audible.
All right. I will just share my screen, and once you are able to view, please do tell me.
Yeah.
Are you able to view my screen?
Yes, it is visible to us.
Okay. First of all, thank you all the participants to join today's call in this tough times of COVID. As I have a brief introduction of me has been given. So my name is Rishi Sharma. I am a principal cloud solution architect in Microsoft, and I have around 23 plus years of experience. I help customers and partners embrace their digital transformation journey on public cloud, that is Azure. Prior to Azure, I've also got experience on working on Amazon Web Services platform. That is also a public cloud platform. And today, what we are going to discuss is, this is the agenda. We are going to discuss about cloud storage and cloud storage with respect to Azure public cloud. So, you know, what kind of different cloud storage portfolio we have on Azure, what are the various types of those storage, and how do we categorize based upon the workloads we work on. I would be covering that, and then how do we use storage for our end-to-end customer engagement opportunities based upon the requirements. So every customer requirement, it rests upon, they have there are business requirements, then there are technical requirements. So we have got the cloud storage pillars which help a customer basis upon their business and technical requirements. We use various kinds of cloud storage pillars. I would be also be covering that. And while I'm going through this, I'll also be giving you a small demonstration of what I would be covering. And I would encourage you to please make this session interactive so that we get the best out of this session. So starting from you have already you have taken the session of the previous speakers. So, but I'll just give again a brief on the same. So Azure is a public cloud where it has got various data center regions all over the world. And in India, we have got primarily three data center regions. That is, one is in Mumbai, which is called West. The other one is in Pune, which is called a Central India Data Center. And the third one is in South, which is called is in Chennai, which is called the South India Data Center. Now, we help these three data centers they are interconnected. The various strings you are seeing on these data center boundaries, these are optical fiber cables. So optical fiber cables means that these data centers are interconnected by what we call as the Azure networking backbone. And the Azure networking backbone is built upon optical fiber cabling. So it gives a very high throughput, very low latency. The bandwidth interaction from one data center to the other is up to 100 Gbps. So this is because all the Azure networking backbone is built upon the optical fiber cabling concept. In India, we have got three data center regions, but all over the world, we have got more than 60 plus data center regions. And all these data center regions are interconnected by the optical fiber pipe, which we call the Azure networking backbone. This is typically how every Azure data center looks, how it is built. So you have got your data center infrastructure, your cabling, your chassis, your servers on the data center. And on top of that, the first layer is the infrastructure layer, which we call the IaaS, infrastructure as a service. Infrastructure as a service, there are three main tenets of that. One is compute, other one is storage, and the next one is networking. So whatever services which are built, which are a part of a public cloud data center, they entail is the infrastructure layer, the compute, the network, and the storage. What we are going to talk today is about the storage, and all these infrastructure layers are complementary to each other. That means that compute has to go hand in hand with storage. Storage has to go in hand with networking. So all of these are complementary to each other. So we are going to focus today on the storage infrastructure service. So if we talk about the Azure public cloud storage portfolio, we have got the public cloud storage portfolio. We have got a storage in the form of disk storage, object storage, and file storage. Now, whatever infrastructure which you saw in the previous slide, the infrastructure on compute means virtualized machines. Virtualized machines, they exist in the form of disks. Then you also have got storage disks. And then the other part is what we call is the object storage. Object storage is the core part of Azure. All your unstructured data sets, all your object type of data sets are available as object storage on Azure. And we have got object storage of two types. That is the Azure Blob Storage and the Azure Data Lake Storage. Azure Blob Storage is nothing. It's an object data set, and that is the core nucleus of the Azure storage. That is the Azure Blob Storage. Disk storage, again, the disk storage, it again at the backend, it exists on top of Azure Blob Storage. And then we have got is the file storage concept in the Azure public cloud, where if you want to migrate, or if you want to create, you want to have a file storage kind of mechanism where you want to access those files through a SMB protocol like you do it on your on-premise. So that is where we use the file storage. Now, along with this, we have got a very efficient data transport service to which helps us to migrate data to and from Azure. So if I want to migrate my data into Azure public cloud, I have got various kinds of Azure data transport service. I have got Azure import export service. Then I have got a physical Azure data box. What this means is that if you have got a very high range of data, like if you want to migrate data to the extent of say 100 terabytes plus, so we have got an Azure data box concept where the that that scale of data is exported into the Azure data box, and then it is imported into the Azure blob storage. Or if you have got the requirement of having Azure uh, to migrate a data, say it is of the of a lesser scale, like it is only say 10 terabytes or 25 terabytes, then we have got Azure import export service where we give you Azure disks where you can use to export your data and import into Azure. Everything in Azure is imported into blob storage. Blob storage is the nucleus of Azure. Everything is built on top of blob storage. And then we have got a hybrid storage concept. What that means is that there are various customers who are having a requirement of having a complete on-premise look of a public cloud. That is where we have got a concept of Azure Stack. But we will not talk about the hybrid storage today. We'll just focus on our public cloud. So if we see the Azure cloud storage portfolio from the left to right, this is primarily what the Azure storage it consists of. Azure storage is durable. That means that you can have durability is a very key ask of every customer. Durable means that your storage data set should be if one goes down, other should be available. There should be a durable copy of your Azure dataset of the kind of storage you have. It should be highly available and scalable. As per your business demand, this storage should be scalable. So all these Azure services which you see here, which are categorized, are built upon these pillars. All are highly durable, highly available, and they are highly scalable. So first is your block storage. I told you that Azure disk storage, which I talk about the operating system disk and data disk, are built upon block storage. Again, block storage, it rests on top of blob storage, that is BLOB, blob storage. The nucleus of Azure is the blob storage. Then we have got your object storage. All your raw data files, unstructured data sets, media files, raw data files are stored in the form of Azure blob storage. And we also have got another flavor which is built on top of Azure blob storage, which is the data lake storage of Azure. So if you have got a requirement of doing analytics, all the analytics data layer is built upon the Azure blob storage. Then we have got file storage. File storage, again, it comes in two variants. One is Azure Files and the other is Azure NetApp Files. Now these variants are there to support enterprise scale file storage needs of customers. So you can choose from Azure Files or you can choose from Azure NetApp Files. And the other component is the backup. Backup means that you want to back up your raw data as a part of your Azure blob storage, or you want to create storage snapshots, or you want to also back up your Azure compute, your Azure virtual machines. So Azure backup is a cloud native service. It is inbuilt as a part of Azure. You can use the Azure backup to create backups of your storage snapshots, that is blob storage snapshots, disk storage snapshots. You can use Azure backups to backup not only you can also backups your file storages. So Azure backup is a key service which is a cloud native service which is inbuilt on Azure. And again, the last point is we have got an efficient service mechanism to import and export data into the Azure data center. So you want to migrate data into Azure, you want to upload data into Azure. How would you do that? You want to do it in a very efficient manner. So we have got these two services of Azure, which will help you to migrate your data into Azure. Azure is a very performance centric platform, and that holds true for the storage part also. We in Azure, uh, in Azure public cloud, we deal with exabyte types of data scale on a daily basis. We have got more than 200 trillion data set objects stored, and more than 400 trillion transactions which are happening per month out of all the data center. So what a storage platform, it demands a very high performance centric and a very high productive centric approach, where the storage which is being used, it should be able to scale up till, like we have got the scale up to exabytes, scale up till to have more IOPS defined, input output operations, scale up till to how to handle high throughput with low latency. So Azure as a cloud storage platform, these are the key performance benchmarks on which it is built. So if you talk about the Azure storage services, I told you, we have got your blobs, we have got your disk, we have got your files, tables and SKUs. They are again, they are available as a part of an Azure PaaS alternative, that is platform as a service. But all, if you see, all these are again built on the IaaS layer. IaaS means infrastructure as a service. That means networking, compute, and storage. Everything is built on top of that. And we have got the in terms of storage, blob. Blob is the object storage. Object storage is on which all others, the other storage pillars exist. The disk which I talked to you about, the operating system disk or data disk, at the back end, they exist in a blob. They are unstructured data sets. They exist in a blob. So if I see what is blob storage is nothing but it is an storage, and it comes in terms of in three flavors. That is block blobs, page blobs, and append blobs. All your raw data, all your raw data in Azure, that means your object data sets, your raw, like your media files, major your data set stores for any database, for SQL, for DB2, for any data set, they exist as block blobs. All your disks, your operating system disks, your data disks, they exist in Azure as a blob storage. But what kind of blob? They are page blobs. And then append blobs are nothing but your logs. All your log files, they exist as append blobs. So blob is the nucleus of Azure cloud. If you see here, all the Azure storage is centered on the blob storage. Blob storage, we talk about all other services, your media, your security, your IoT, your machine learning, all are in at the back end. They exist as blob storage. And blob storage, nothing but it is object storage. Object storage means unstructured data sets. When we talk about your media files, we talk about your uh, event stream files. They all are in Azure. They are existing at the back as blob storage. So blob storage is the foundational storage service, and it is a very, as I told you, the pillars on which it rests. Each storage platform rests upon the 5 pillars which you are seeing here, that holds good for blob storage. That is, it has to be durable and available. What it means is that if you are having the storage in, say, Mumbai data center, it should, if that data center goes down, the same replica should also be available in the other data center region. That is, it should be durable and available. The other is it should be secure and compliant. No one from outside can access your blob storage without relevant permissions based upon the role you are performing. And there are various security mechanisms which we have in Azure on Azure storage for accessibility. Then it has to be scalable and performance centric. Based upon your demand, your storage should easily scale up. For a hyperscaler cloud like Azure, scalability is a key ask. It's a key parameter for the public cloud. And then it should be open and interoperable. What that means is that the public cloud storage, it should support open APIs where I can access my storage not only from my, say, from my programming language or from my any third-party clients. It should embrace open source. And this, the last point is very important, is whatever storage you have on Azure public cloud, on a public cloud hyperscaler platform, it should be manageable. That means you should be able to monitor and manage it, and also you should be able to manage cost. So if your storage is, if supposing you have provision storage and it is consuming more cost, you should be able to have the relevant tools and services to manage those costs, to optimize those costs on your storage front. So these are the 5 pillars on which Microsoft Azure Blob Storage is built upon, and these are inherent as a part of the Azure platform. Whenever I create any storage on Azure, I have got all these tools and services available for me to make that storage durable and available, to secure it, to be able to scale up as per my need, to be able to access it from open platforms, from open source APIs, and to be able to manage storage and make it cost efficient as per my customers ask. So if you see on Azure, on the Azure platform, if we talk about, say, a big data platform. So a big data platform again on Azure is built. It is built on top of blob storage. So I have got all my, if I talk about big data is a open source. We have got in Azure, the equivalent of big data as a service is HD Insight. Azure HD Insight is nothing but it's a managed service of big data on Azure. But again, on what is it built on top of? It is built on top of my blob storage. If you see the other analytic services, I have got my machine learning, my data lake, my Azure data factories, all these various data services, log analytics, these are all Azure services for me to use as per what kind of workload I am working on. If I have got a need of working on a data warehouse, I have got a SQL a data warehouse solution. If I have got a need to work on a IoT, that means on an IoT case, I have got an IoT hub as a service. But again, these all exist. The data layer, the data set on which they exist is blob storage. And the 5 pillars I talked about blob storage, they are applicable to all these data services. It is up to the customer, because these pillars, if I want to implement these pillars, the services and tools are available on Azure. In terms of disk storage, again, disk, it exists at the back end in the form of blob, as page blobs. It's nothing but blobs. But when you go and create a virtual machine in Azure, a virtual machine in Azure is created as a part of an OS disk, operating system disk. The disk in Azure, it can be an operating system disk, and then you can attach data disks to it. So it is operating system disk and data disk, and they are available in Azure in two flavors. One is your normal HDDs, like your magnetic drives, and the other one is solid state drives, SSDs. I have, based upon my workload, based upon a customer's workload, I can use HDD or SSD. Typically for high-end workloads like for SAP or for HPC, high performance computing, or for other high-end workloads, I normally use the normal SSDs, that is solid state drives. Now solid state drives also comes in three flavors. One is your normal solid state drives, the other one is your premium solid state drives, and the new kid in the block which has come is the ultra solid state drives. All these, the major difference is that your normal solid state drives, based upon the amount of IOPS and bandwidth they offer. So a premium solid state disk drive, it gives you a dedicated IOPS, more IOPS with a good bandwidth. Ultra SSDs, they offer you highest IOPS. They offer you highest IOPS with the highest bandwidth. So based upon your workload, what is the requirement for your workload? What kind of IOPS for your IOPS input output operations your workload demands? What kind of throughput requirement is has? What kind of latency? It has to have a very minimal latency. Based upon that, we choose from these Azure disks. But again, these Azure disks, I told you, they exist as operating system disk or data disk, and they come in these flavors too. One is HDD, one is SSDs. So all these, if you see a operating system disk and data disk, they come as managed and unmanaged. Managed disk means that at the back end, these are managed by Azure. So for example, if I have created a virtual machine of say a Linux virtual machine or a Windows virtual machine, it will exist as a Windows OS disk or a Linux OS disk. If this goes down, if this disk for any reason corrupts, Azure, since I have created that disk as a managed disk, Azure will make sure that this disk it would be durable. Like the other, if it by chance it gets corrupted or it goes down, the other disk is available for the same. So, and the same thing holds for my data disks. So we always, as a part of our any disk creation, we use managed disks. Unmanaged disk means that it is the responsibility of the customer to do to handle durability. But if we go by managed disks, it is the Azure inherently manages the durability of the disk for the customer. So both operating system disks and data disks, they come as a part of managed and unmanaged. Unmanaged will soon go. It will soon go because now everything Azure is offering is as a managed disk option. So Azure files, if I talk about Azure files, it is nothing but where you have got your files as you have on your on-premise setup, your Windows files network. The same you want to create on a public cloud platform like Azure. You want to have a file system which should be accessible, which should be scalable, and also which should be uh, uh, cross-platform, which I can access from my Windows machine, from my Linux machine. So Azure offers Azure Files as an option to build that. So if you see how does Azure Files work, I am having a on-premise setup, and on my on-premise setup, I have got my file systems on my desks. I have got my Windows desk, my Ubuntu desktop, I have got my other desktops, and all these are having their individual file systems. Now what I want to do is I want to replicate this file system onto Azure, and I want to sync this with the Azure file system so that ultimately all my files which are having on-premise are synced into the Azure files on Azure. The typical protocol which I used is the SMB protocol for my file management and for my sync. It is up to me. So when I have to access any file share, the same as I do it on premise, my file share, I can do the same thing on Azure. So once I create a file share over here out of these sync mechanisms, on Azure, I've create a URL which will allow me to not only share my files but also to sync. So Azure file works as a hybrid file share system. Whatever file share system I have on premise, I can easily replicate that to Azure files with the SMB and REST protocol, and all updations I do here on premise, I can sync those onto my Azure public cloud. So this is where I have got a requirement of a file share requirement. Blob storage pillars, I told you that all storage is it exists on Azure as object storage, that is as blob storage. First, I'll talk about the durability and availability of your storage. So in our Azure public cloud, I talked about that we have got various data center regions available all over the world, and in India we have got 3 data center regions, that is Mumbai, Pune and Chennai. Now when you create a storage, blob storage as a part of a storage account in a data center region, you always create a storage account. It is nothing but a resource. Everything in Azure is a resource. Compute is a resource, network is a resource, Azure storage is a resource. When you create a storage resource, Azure by default it gives you creates 3 replicas of that storage in the same data center region. So if I create a storage account into say Mumbai data center, Azure will create and choose LRS, that is local redundant storage, as my storage option. Azure will create 3 more storage replicas into that data center region. But if that data center region goes down, I don't have the storage replicas available in other regions. So now I have got another options of ZRS and GRS. ZRS is nothing but zone redundant storage. That means zone one means different data center building. Zone 2 means different data center building with its own power supply. Zone 3 means different data center building in its own power supply in the same data center region. So say for example, in Mumbai, I have got zone 1, zone 2, zone 3. That means in Mumbai, I have got one data center location having its own building, another own building around 50 kilometers apart. GRS is geography redundant storage. What that means is that I am having this storage as a part of my different geography. That means Mumbai is one geography, one data center region, and Chennai is other. So I choose GRS. What I have got the option to choose here is that whatever storage I am creating for on Azure, it is up to me. I want to use the local redundant storage option, LRS, the zone redundant option, or geo redundant option based upon my durability and availability. So this is built upon customer, but Azure offers. So if I take ZRS or GRS, in case of GRS, Azure will create six replicas, three in one region, three in other region, so that if one region goes down, my storage replicas are available in the other region. And these replicas which I have, I can only restore them when our data center goes down. If I go for RA GRS, I can anytime read the other storage replicas. So durability and high availability is very important for storage in a public cloud platform. If one of my data center region goes down, I must design and choose the durability option of Azure so that my storage is available in other data center regions. So if I talk about the storage, I am talking about both the object storage and the block storage. Object storage means my blob storage. Block storage means my disks. So let me just go and show you an example on my Azure portal. So supposing if I am going to say create, this is my Azure portal, and I have logged in as a part of my subscription. Every customer has got a unique subscription attached to them. If I want to say go and create a storage account, right? So I just type here storage account. Now it is asking me to create, I will say go and create a storage account. Now here every storage has to be a part of a storage group. Every resource has to be a part of a resource group. That is a requirement of Azure. I create a storage or a compute or a network. It has to be a part of a storage group. I can choose existing or I can create new. Supposing I will just create new. I need to give a storage account name. So what I'll give is I will give so if you are seeing I have to choose a data center location. If I choose these are the data center locations which are available to me to create a storage account, I will create in Central India. But it is saying this storage account name is already available. So I will just go and create. This name is available. And now if you see here, right, when I say here storage account, I will create a general purpose or I can also create a blob storage. If I create a general purpose storage account version 2, what that means is that my storage account will consist of all these pillars. If I create a storage account with general purpose, I have got the option that storage account will consist of blobs, tables, queues, and files. Everything will be there. But if I only want to create a blob account, I have all the option of blob storage also. For the meantime, I'll just go and choose this. If you see the replication option here, this is very important. It is to ensure durability and high availability. What that means is that the storage account which you are creating, in this you will be having your blob storage, your file storage, all kinds of storages. You need to make sure that you want to choose what kind of replication option. If I choose LRS, that means when this storage account will be created, Azure will create only 3 replicas into my Central India data center. But if I choose geo storage, in this case, it will create 3 more replicas in the other data center which I choose. So it is up to me what kind of durability I want the Azure to, as a customer requirement I want. Durability and availability. So let me keep it for LRS right now, and I will just go and create the storage account. So if you see, when we create a storage account on Azure, we can also create this as a part of our templates we have. I'm just doing this through the Azure portal. So it is saying what is the data center location, Central India. This is my storage account name, version 2 storage, and my replication is LRS. So when I want to now one more thing I want to just show to you is that everything in Azure is a template based approach. So if I go here and I say download a template for automation, automatically Azure, whatever I create in Azure, automatically Azure, it creates a template. This template is nothing but a JSON template. So if you see here, I have just created a storage account. It has created for me a template for this. I can reuse this. Template. I can also create a storage account using these templates, and hundreds of templates are available on Azure portal basis the resource which you want to create. So it is just everything in Azure is a template based approach. That is automation template based approach. And this template is nothing but it is a JSON template. So I can create any resource. It can be a storage or compute using a template if I know how to create a template. So for example, now I just go and create this storage account, and it will create the storage account in my Central India data center region, but I have only given it the LRS option. So it will create 3 replicas. All right, so I'll just go back to my desk till the time that storage account gets created. So if you see here, my deployment is complete. I can go to my resource. This is my storage account here, right? My storage account, it is part of a resource group which I had created. This one resource group, it is lying in Central India. It's a general purpose storage account. What is the replication type? LRS. LRS means that, again, local redundant storage. And if you see, I have used general purpose, so it has created these storage services for me. In this storage account, I can create blob, I can create files, I can create tables and queues. If I had only chosen blob, it would have only created a container for me, not these options. So since I chose the storage version 2 general purpose, it created all these options. And if you see here, I can, to access my storage account, we talked about open APIs. To access my storage account, I can access this through various mechanisms. I have got a desktop application which is available free of cost for all platforms, for Windows, for Linux, for Mac, called Storage Explorer. I can do it through a PowerShell. I can access my storage account through a PowerShell scripting language. Same way, I have got a Linux scripting language called CLI, or I can access this through a .NET API, a Java API, a Python API, or Node.js API through an API layer. So if you see here, right, Storage Explorer, I already have a Storage Explorer on my desktop. Anyone can go and download a Storage Explorer for Windows, for Mac, whatever you're using. And once you download this, when you open this, you just need to connect to your subscription. If you see here, I have got my subscription over here. And if I go and see this is my subscription. Every customer has got an account and a subscription. This is my subscription ID, Microsoft Internal Subscription, and this is what I have logged in here. So if I just go to my storage accounts which I have created right now, and I just refresh them, you will see here, Rishi Store. I just had created this onto a central India data center with LRS as replication object, as replication mechanism, and I am accessing this through my storage explorer. So if I go here, it is giving me these options: my blob container, my file shares, queues. I have right now not created anything here in blob. I don't have anything here. So I can go and create a blob container here, right from my uh, storage explorer. Or I can also do the same thing using the portal or through these mechanisms. So my interaction with my storage account, what I have is through open APIs over which I have open source, open SDKs. And the next part is how to access. That is very important. Not everyone should be able to access your storage account. You must have, based upon the relevant roles you have in your organization, you must give permission to those roles to access the storage account, and what should be the access mechanism. So if I go to my for security again, it means what is the role which is on this. Now supposing you have got in your organization a storage administrator role. Only a storage administrator role, and you can have multiple users for that role, can access my storage account. So if I go back to my storage here, I have got access control. That is, who is which role can access my storage account. This is my storage account. I want to create a permission to a particular role. Only that role can access. Supposing I am a web developer or I am a database administrator, I should not be authorized to access a storage account, only a storage administrator. So what we do is that we go to role assignments. We first create any role we have, any user we have, we create that using Azure Active Directory. So let me just show that to you also. So if I go here, every role we create is through through the Azure Active Directory. So I can go and create a new user over here, or I can create a new group, and based upon group I can add users. And then once I create those that role user, I can go back to my storage account, go to the access management, and I can add a role here. So I want to add a role assignment. What role I want to create? I want to give complete ownership rights to that person, to that storage administrator. Right now, to whom I want to uh, uh, give these ownership rights. So say I have got a it is not there. Yeah, I have got a role called SAP CRM. This is my role. Okay. Once I click, I have to save. So once I have given this ownership, only that role would be able to access my storage account. That as per the role. The other thing is, how do you access the storage account? What is the uh, uh, interface interface mechanism to access any storage account on Azure? That means once I have got that role who wants to access it, what should be the access mechanism? Do they need a URL? So in Azure, we have got two concepts to access any storage account, any storage account. That is, it can be a blob storage or it can be a file storage. One is your properties. So there are two. If you see here, for blob service, I have got a unique property ID. For file service, I've got a unique property ID. So I will give this to the respective role to access my storage account. They have to use this property ID for to access my blob service. This is the URL for my blob service, but this, when they enter this, they need to also enter the complete property ID to access my blob under my storage account. These are all my storage services which I have, which I will create. But to access them, first it has to be what is the role, the ownership. I just showed you that, and the other one is how to access it. What should be the underlying protocol? How should be the what should be the access URL? Access URL has to be a very unique encrypted URL, and this is how we give it. There is another option called shared access signature. So what I means is that I can give a right to a role that you can access my blob or my file or my other service using at a particular time of the day, and after that access won't be uh, required. I mean, that won't work. So in my storage account, it is up to me how I define my storages in Azure public cloud. And once I define them, as I just told you, I've created this storage account. I can also create that using a ARM template approach through a JSON template. And then how to access it. So if we go back, right, I showed you these are the common ways how to access. So these are my storage services. I just showed you. It can be a blob storage, it can be a file storage, it can be a queue, it can be any type of storage. I need to have appropriate tokens to access them. What are the different type of tokens? One is your property. This is my property, and this is the URL for me to access my storage account. I will only share this with the required owner. I can also, if I say refresh, this property will get refreshed as I refresh this. Or I can use the shared access signature to secure my access to my storage account. Right? So if you see here, right, and then how the one more key concept on Azure is that whatever data I have in my storage account, it should be encrypted at rest. So my data, it's my raw data, right? But it's a very highly customer centric data. It has to be encrypted at rest. So how do I do that? I do that. I have got the respective mechanisms to encrypt data at rest for my storage account using the encryption set with a Azure Key Vault service. Then I have got one second. Yeah. Then I have got my. I talked about security and compliance. Then I have got my management and the cost effectiveness. How do I manage my cost? So in Azure, when I create, if you see here over here, I have got this as a performance is standard hot. What that means is, why I have chosen hot is I this is where I need immediate access to my data. That means in real time, this hot tier would be having immediate access. That means all the transactions would be happening here. In Azure, we have got two other kinds of tiers for our storage. So hot means frequently accessed. The other one is cold tier and archival tier. Cold tier means that the data I want to access is on a less frequency. That means maybe once per month. Once per month I would be accessing. But hot means I am doing every day. Every day I am accessing my storage of hot tier every day. I can have a storage account created for a cold tire because I need to access that storage account only once in a month. And I can create a storage account as an archival tire. I need to, that means rarely access data, which I need to access maybe once in 6 months. So if I talk about a workload like, say, a very key workload like SAP, what happens is that for SAP, typically we have got all these, we use all these tires. We create frequently access data tire as hot tire. Then we have got backups in SAP, which we create and we only use once in a month. And then we have got long-term historical data, which we keep as archival data, which we might require once in a month or once in 6 months or once in a year. So based upon that, your cost also is managed. So the cost for frequently accessing data you can see here as per the tire which I have chosen. So if I, in my real time, I would have created a storage account as hot, cold and archival based upon what is are my requirements for accessing that data. So we also have got partner solutions, third party partner solutions available which work very effectively on Azure. These third party solutions, again, they create effective, say, backups on Azure, but ultimately, again, whatever is being done is done on blob storage. Everything is done on blob storage. So scalability and performance. Scalability is a key ask of a hyperscaler public cloud like Azure. Scalability means that based upon supposing I am running a e-commerce application, or I am running a retail application, or say I am running a government application, say where I am at one point of time I am having concurrent users keep on increasing. So in one day, in a time window from 11 a.m. till 3 p.m. its peak load means that say 50,000 concurrent users are accessing, and they have to also commit their data. So the storage has to be highly scalable and performance centric. And then what happens is that after 3 p.m. the access say goes down. The if concurrent access say is from 50,000, it goes down to 10,000, and then the storage transaction in terms of IOPS and throughput also come down. So we need to have a storage platform which is a hyperscaler storage platform which can scale as per what kind of IOPS requirement are required as per the business usage demand pattern. So if I talk about, say, at any government site, if I'm going, say, for any Aadhaar site, normally at night time you won't see that amount of interaction, but at one point of time in the day, right, it will be the access would be very high, and then at at a similar time of time a lot of data is being updated at the back end on the storage. We need to have a scalable platform which can scale up to petabyte of data as per the usage demand. That is what Azure Blob Storage is built upon. It's a hyperscaler storage. It's a hyperscaler storage service. I can scale up from petabyte to terabyte to uh, to say from 10 terabytes to 100 terabytes in a minute of seconds or minutes to support that business need. So I talked about open and interoperable, which is I am trying to access my storage through multiple platforms, multiple services, multiple programming languages, and multiple mediums. I can access my storage account through a scripting language which is open source like Azure CLI, or I can access this through PowerShell. I can access my storage account through a desktop based app which is again a cross platform app like Azure Storage Explorer. I can access my storage directly from the Azure portal. I can also access my storage accounts, my blob storage or my file storage through a programming language API like a Java API or a .NET API. And I can also access through multiple, the APIs are there, but I can also access through multiple device platforms. It can be through my Android app, it can be through my IoT app or a cross-functional app. So openness approach in terms of accessing my storage account is what Azure hyperscaler public cloud platform supports. So I just showed to you that this is my, I can access my storage account here based upon the role I am. If I have got the relevant permissions, I have my storage account here. I can go, and right now I don't have any blob created. I can go and create a blob here, right? But I must have the permissions to do that. Now supposing I just say create blob 1. So if you see here, right, I have, it is up to me to define what kind of access. So if I say private, that means I am, as a storage administrator, I am creating this blob storage tier, and I would be giving the relevant public, the relevant access to a role, how to access my storage account, how to access my blob storage account. So right now I just say for read only, everyone can do this. This is my blob here. Now you are seeing I am interacting this with a portal. I can do the same thing here if I go and I just refresh my storage account. This is my storage explorer, which is nothing but a storage uh, access application, or which is available for Windows, for Linux, for Macs. So if I go and create, you will see here is my blob which I have created. Right now I created this. Right now I don't have anything in my blob. Blob is number, it is, this is my core data set. This is my blob. Now for me to access this blob, manage access policies, I can have an access policy as an administrator, as a storage administrator. And then based upon that, I'm going to define that who all can, what is this is my blob storage ID. You are only, you are required to read, or you can also required to write. And I add this, right? Again, I can write other access policies here. Right now, I don't have anything in this blob. I can have any kind of raw data set. I can have unstructured data set. I can have even any structured data set here. I don't have anything, but I've just shown you how to create a blob. Everything is existing as a blob. And then the access to this will happen. Here I can upload any media file from here, or I can upload anything, any data set from here. But I need to make sure that who is allowed to access this, my blob storage tier, and with what. So this is what my, for my blob, I am saying you have to have the respective, this is my blob service URL. You can embed this with this ID, with my property ID into API, or you can use this through a storage explorer, or you can even use this through any programming language, or you can use this directly through a scripting language like Azure CLI. But I am enforcing that for accessing my storage account, you must have the required property ID to access my blob storage tier. Okay. Now, all our Azure data lake is one another block object storage, which is again built upon the blob storage foundation. Everything is built upon blob storage. So data lake is Azure data lake. It encompasses the complete data analytic lake, that suite, and where I need to ingest my data, process my data, and maybe pass it on to Azure ML service or an Azure IoT service or an Azure chatbot. But again, Azure data lake, again, if you talk about and how in the data service concept, we have got a data lake concept. Data lake concept, can you have got open source frameworks where you can build your own data lake. You have got other hyperscaler cloud providers. Similarly, on Azure, we have built our data lake platform on Azure Blob. Everything is built on the Azure Blob storage platform. So I talked about the big data platform on Azure, which is HD Insight, which is built upon the Hadoop file system. That is again built upon the Blob storage foundation. So if you see here, right, this is our Azure data lake storage architecture. Accessing the access to this data lake, it is again through the generic blob API, which is available for every storage account. So I talked to you about, I showed you this. This is my blob storage and my blob access. This is nothing but a blob API. For me to access my storage account, I'm using the blob API handle here, my blob API access. In my data lake, I can use the same blob API, but there is another API which is built for my data lake, that is a Gen2 API. I can use that. But again, the Azure data lake, it is built upon the same principles of durability, accessibility, openness, and security. So we also have a serverless concept in a hyperscaler cloud like Azure. Serverless concept is that your code will run based upon an event. If an event occurs, your code will run. Otherwise, your code will not run. So that is what the concept of a serverless is. In Azure, we have got a serverless which is covered through Azure Functions. Your code will, your function will run, which can be built on Java or .NET or other Node.js APIs. And we have got a workflow, a serverless workflow called Logic Apps. Now, these are all tied with our blob storage. What means is that we, based upon whatever we have in our blob storage, any kind of data which comes in our blob storage, if we want to create a automatic workflow, say supposing if my blob storage some anomaly occurs based upon a data set, I can use that event to trigger the event grid service in Azure and use the serverless compute. So blob storage events are now very, based upon whatever event is occurring there, that can be tied to our serverless approach through our Azure Functions and Azure Logic Labs. In Azure, we need to upload data, we need to download data. So whatever we upload data, it is called egress, ingest. So it's called egress. And whatever we download data, it's called egress. For us to upload data into Azure Blob Storage, we have got various ways to do that. We can use Azure Data Box, which is a which is a bare metal box, but that is used where you have got very large amounts of data to upload into Azure Blob. Or you can use Azure import export through an Azure disk, or you can also import data into Azure directly using a dedicated pipe like Express Route. If you want to upload a data from a on-premise customer network onto Azure in a blob storage, there are various mechanisms available. I can use a dedicated pipe which is called Express Route, which is a dedicated MPLS type. But that would and it comes in various bandwidths up to 10 Gbps. But that has a cost associated. Or I can also use the data box concept. So I would just like to talk about in the last about the Azure NetApp files. So Azure files we've talked about. If we want to create a file system, if we want to synchronize the way we do it on our on-premise onto Azure, we have got the Azure file concept. Azure NetApp files are nothing but they support enterprise workloads. Enterprise workloads like SAP, enterprise workloads like HPC. SAP and HPC, they require enterprise storage file management, where the storage is in high cluster, where it needs to be, where they have a very common shared mount. Supposing you have got two Linux clusters running and they demand enterprise level shared storage. Azure NetApp Files supports that. That is, and again, it is built on top of Azure Blob. Azure NetApp File is again built on top of Azure Blob, but Azure NetApp Files is used for high-end workloads like your enterprise, your SAP or your HPC, which demand enterprise scale storage, enterprise scale shared storage, and enterprise scale file management. So the last part is that I talked about in the beginning is the Azure backup. Now we have got an Azure backup center in public preview. It would be soon globally available in all data centers. So whatever backup you create for your Azure workloads as a part of your Azure blobs or Azure files or any other VMs, again VMs would exist in as a part of Azure blobs. You can govern them, you can monitor them, you can manage them, you can do operational insights right from one console, which is the Azure Backup Center, which would be available on the Azure portal. So if I go right now to my Azure portal, I have got a service called here Azure Monitor. With Azure Monitor, I can monitor my end-to-end infrastructure resources. I can monitor my virtual machines. I can monitor my storage. I can monitor my network. If I talk about monitoring my storage accounts, right, which I have just now created. So supposing it is saying here is I am now using Azure Monitor to monitor my storage account. So if you see here, if I just go and click, this is available out of the box. What it is saying is that for my storage account, these are the number of requests I have. These are the number of transactions. Right now, I don't have anything. And this is what my utilization of my storage account is. What is my blob transactions? What is my file transactions? Because I don't have anything here. I only have blob. So end-to-end detail it is giving here my Azure Monitor. The same thing it would do for my compute for my network. But going beyond, Right now we have got Azure Monitor. Going beyond, we will also have called Azure Backup Center. So whatever backups I do for my storage accounts, my blob tier, I would be having an Azure Backup Center where I'm going to again monitor, manage, operate, optimize all my backup which I have done on my storage accounts. Like I'm just monitoring right now. So what I'm doing, I am gathering here insights for my storage account which I have created. If I go back here, these are all my storage accounts. This one which what I just created. So it is saying for my storage account, this is my latency, which is and I can also customize this. So what I'm trying to show to here is that whatever we create, whatever storage we create on the Azure Hyperscaler public cloud, we monitor it, we manage it, we operate it, we can optimize it, we can also do cost management for it. So this is tab is for my monitoring end to end. How much is my blob tier consuming? What are the patterns? What are the transactions which have happened to my blob tier? Right now, nothing has happened. What is the availability? Because I have not used this is 100% over here. But supposing if in real time, supposing you have got this storage account, it's a blob tier account, and you have got it's a web application which is supported by this storage account at the back end, and you are having concurrent users. It says it's a government application. You're having concurrent users, and at that point of time, you are saying that in every second, hundred like millions of transactions are taking place. So you will be knowing that how much is the percentage availability of the storage account over here. You will have all these metrics which I can use to efficiently monitor and manage my storage tier. It can be a blob tier, it can be a file tier, it can be Q tier. Now, if I had only created a blob storage account but not a general purpose, I will only get my blob parameters over here. So coming back that whatever we management, monitoring and cost efficiency, this is how we do it in on Azure for storage account. So just to do a last wrap up, what kind of storage we have on Azure? We have got object storage, we have got this storage, we have got file storage. The nucleus of Azure public cloud is blob storage. Everything exists as a part of blob storage, all our unstructured data sets. Your disk also exists as a at the backend as a part of blob storage. What are the different ways of importing data into Azure into blob storage? Using an Azure data box or an import export service or through express route. And these are some of the key customers like topmost which are using Azure storage platforms from all point of view which we have discussed, from a hyperscaler, from a cost efficiency, from management, from durability, accessibility, from high availability. We have got we have got many customers, but these are some of them which are using the Azure storage based upon all the pillars which I just mentioned. All right, I am done. If you have any questions, I'll be happy to take them.
Any questions for Mr. Rishi, dear participants? Okay, it seems there is no questions from participants for you. I hope they all understood properly whatever you have presented. And thank you, Rishi, Mr. Rishi, for giving your time and putting this presentation in front of us. This was yes, it was a great to listen you about regarding this Microsoft Azure storage and all things. And
also, if anyone, if at any point, if you want to reach out to me, I'm just sharing my ID here. If for anything you want to reach out to me on Azure, on storage, on any aspect of Azure, I'll be more than happy to help.
One question I saw now in chat: how can we compare Azure storage and Google Drive?
Yeah, so Azure, that's a good question. Azure storage, AWS storage, and Google Drive storage, they're all the underlying storage built concept is the same. So like in Azure, we have got object storage as a part of blob storage. In AWS, you have got, you called it S3. Same thing in Google, it is an object storage data set. So it is the storage pillar on which it is based. It's a cloud native storage concept. You build that on top of your hypervisors layer. So the storage build concept is the same. How do you build your your storage APIs on top of that? That is what is different for each public cloud.
Okay, I hope Mr. Ankul Goyal sir got your point. Any questions further? Okay, so thank you, Mr. Rishi. We'll be ending our session here. Thank you so much.
Thank you very much. Thank you. Have a good day, everyone.
Yeah, thank you.